In this video, I will show you how to adjust the work plane and how to model members. We will also create sections and materials. Before we get into all of that, I would like to show you how you can change the background color in RFEM. First, we can go up to Options and then Display Properties. If you would like to change your background between dark background and white background, down here is where you can do it. The first thing we want to do before we start modeling is customize the grid in RFEM. To do this, we click on the respective icon, work plane, and grid in the toolbar. In the new window, you can create a user-defined coordinate system in the upper part and define the orientation of the work plane as well as the origin coordinates. To have faster access to the orientation of the work plane, you can also use the respective symbols in the toolbar. Let's set the orientation of our work plane to XZ. You can find the grid properties in the lower part of the window. You can show or hide the grid. Additionally, you can enter the number and the spacing and the grid points. You can also activate a dynamic grid that automatically adapts to the size of the model. In addition, you can activate the snap to grid points in the window. If needed, you can adjust the number of pixels controlling the snap distance. In this case, the cursor is pulled magnetically to the grid points when it is close to them. When we are satisfied with the settings, we confirm the data in the dialog box by clicking OK, and then we can start with the modeling. No data has yet been defined in our structural model. We can recognize this by the fact that there are no drop-down arrows in the menu under the basic objects in the data navigator. First, we set nodes in the work window to define the start and end nodes of the members. This step is optional because you can also insert members without defining the start and end nodes beforehand. However, it helps us to gain a better understanding of modeling. So let's click New Node in the toolbar. Now we can set a node using the dialog box or graphically with the crosshairs. We decide to enter the data graphically and click the origin. The coordinates on the crosshairs are very helpful because they show the exact position. The activated snap helps us click the coordinate node. Since the column has a height of 14.5 feet, but the spacing of the grid points is 1 foot in all directions, there is no grid point at 14.5 feet that we can click. Thus, we have to set the second node using the dialog box by entering the desired coordinates and then clicking Apply. To set our first member, we click on New Single Member. In the new window, we now define the properties of the member before we create it. In the Main tab, we first select the member type by expanding the respective list. Since we want to model a column, we select Beam as the member type. Find more information about the individual member types in the link below the video. Further into the course, we will become more familiar with other member types. Under Options, you can find more properties that you can assign to the new member, such as hinge, eccentricities, and much more. At the beginning, we're not going to select anything, and we're just going to select the Section tab. In the Section Distribution area, all available distribution types are listed. The bitmap on the right of the window helps you to visualize the respective distribution types. In addition to a uniform section distribution, you can also consider a linear or tapered distribution. In the next area, you can set the member rotation. For our column, we leave both options as default. In the section with material area, we will create a new section for the member by importing it from the section library. In this Select section from Library dialog box, The most common standardized and parametric sections are arranged in categories. In the standardized steel category, we select a rolled I-beam to display all available sections of this category. In this dialog box, we can now select the desired section for our column. But first, we will familiarize ourselves with the options. In the left upper area, you can change the section category without leaving the window. Immediately below that, you can find various filters which help to clearly limit the selection. A new feature in RFEM 6 is the practical search function at the bottom of the window. Let's try it out by entering AISCW. All available AISCW sections are now listed, and we can select the desired one. Afterwards, we have to create a new material for this section. To do this, we click on the Import Material from Material Library function in the Material area. The Material Library is structured similarly to the Section Library. On the left are the filters, in the middle, the respective list, at the bottom, the new search function. We would like to use the steel A992 material. So in the region field, we can select United States, and in the material field, we can select steel. Now we have restricted the selection and can easily search for the desired material. We select steel A992 and confirm by clicking OK in the dialog box. We have now defined the material for our section. Another helpful feature in RFEM 6 is the display of unit stress diagrams for the sections. A kip foot is applied as the load, and a desired stress distribution is displayed from the list. In addition, the statical moments and the center of gravity as well as the shear center are displayed. Depending on the options set in the main tab, and initially in the base data, additional tabs appear in the new member window. These tabs allow for further calculation parameters for the design. You can also add hinges and eccentricities. We'll do all of that later, and now we will confirm the entry of the new member by clicking OK. We create the first column by clicking the previously created nodes one by one. We end the action by right-clicking or by hitting the Escape key on our keyboard. Thus, we have inserted the first member in our structural model, and we have also reached the end of today's tutorial. Until next time.